In this series about congruent triangles, we've talked about the side-side-side theorem and the side-angle-side theorem. Next today is the angle-side-angle theorem. In order for this to not work, I would extend the sides of both of these and I would get triangles that are different sizes. Is that possible to do? Let's see what happens. Okay, I drew the two triangles. They look congruent. It looks to be the same size as the other one. Same size, same shape. So this is angle, side, angle. Angle, side, angle. That combination of congruent parts, these two, and these two, are going to force the two triangles to be congruent, and that's all you need to check if you get that combination. Let's look at the examples. In this first one up here on the top with these right angles are always congruent. So there's one pair of congruent angles. You have a pair congruent sides that are marked, and you have another pair of congruent angles that are marked. But what you really are looking for in these diagrams, once they're marked up, is that the side is between the two angles for both of the triangles. Let's look at this one over here. I have angle, angle. Then you have a shared side, which is awesome. We can use reflexive property. And then another pair of congruent angles. But remember, that side is between the angles, right where we need it to be able to use angle, side, angle. This third diagram, there's a pair of congruent angles, and they're telling us that these sides are congruent. You may think you don't have enough information because these aren't marked, but remember, vertical angles, that's a definition. You don't need to be told that. You can assume that. Just make sure that the sides are between their angles. And in this last one, this isn't going to work, but let me show you why. You've got your vertical angles right here, and then you have a side, but they're not telling you anything about the next pair of angles that would have to be the case. If this was going to be angle, side, angle, they'd have to tell you about those angles, or you'd have to be able to figure out that they're congruent. Right now, the way this picture looks, given no other information, I'd say we can't say anything about those triangles. Okay, what other information do you need to prove that these triangles are congruent to each other by angle, side, angle? Well, I've got one pair of congruent angles, and I know I have a side, so the side needs to be between the angles. So if these are the angles given, then we're talking about these angles right over here. So I would need to have, for that last pair of angles, I would need to have these two things be congruent. Okay, so to write that out, TSN is this one, TSN, and TSU is TS down to U. Okay, again, we want to go angle, side, angle. There's our two pairs of congruent angles. We need the sides that are between them to be congruent. So this would be K to J and N to M. All right, this one's a little more confusing, but this is like a proof we're about to do. So I wanted to go over it, and you're going to see these in class if you're taking geometry in class. These little red triangles here are telling me that these two lines are parallel. If you have parallel lines, then you get to use all of the corresponding angles, alternate exterior, alternate interior. You get to use all of that stuff. They're giving me one pair of congruent angles, and I have a shared side right here in the middle. BD is congruent to DB because of reflexive property. I need to somehow get these two angles to be congruent to each other. How would they be congruent to each other? That's a true statement, but why? We'll go back to those parallel lines with transversals lessons. There's your two parallel lines. That shared side is the transversal. These guys up here are alternate interior angles. So CBD is going to be, this angle here is going to be congruent to ADB because they are alternate interior angles. That's going to sneak into these problems in this unit. Like right now, we're going to do the proof that goes with that diagram. Angle ABD is congruent to CDB, so let's mark those. Always mark your diagrams first, guys. All right, then what else do we know? Well, I got the shared side. I'm jumping ahead right here. I know I've got that side right here. But then they're telling me that the lines are parallel. And we knew that already because the diagram is marked with these parallels. But if they don't have the little marking of parallels marked, that those two things are parallel. And as soon as you have parallel lines, you know you can use those alternate interior angles. Make a little note to yourself on your diagram, because as you start the proof, if you forget why, you can look over on your diagram. Once your diagram's all marked up, and you know what you're going to be doing, in this case, it's going to be angle, side, angle. We know that angle ABD is congruent to angle CDB because that is given. And that's our first angle. BD is congruent to DB, reflexive property. Hopefully you're getting that really well by now. I've purposely included lots of proofs with that. There's your side. Now we need another angle. Well, we can't go right at the angle yet because it's those alternate interior. The first thing we have to do is talk about this being parallel. This is one of those situations where I'm not going to always start with this given. Like I didn't do that first because I didn't need it until right now, because now I'm going to say that those two angles are congruent, and the reason is alternate interior angles. Remember, you cannot say something, you can't use it as a reason for a statement. Alternate interior angles are congruent. I can't introduce that into my proof until I have shown that those two lines are parallel in some way, and in this case it was given. Once I have that, that's my angle. So now I have angle, side angle. I can say that the two triangles are congruent by angle, side, angle, congruency theorem. Okay, side, side, side is done. Side, angle, side is done. Today we did angle, side, angle. The next one's going to be angle, angle, side. If this video is helpful, will you please share it with somebody who's in your geometry class or someone you know who is in geometry? As always, thank you guys for watching, and I will see you in the next video. Bye!